In this video, I'm going to show you how I made a program to generate these funky desk organizers using a library called OPENCASCADE. I'm not really going to go far into the weeds with the programming side of things, but I'll explain which functions I used. And I'll post a GitHub link if you'd like to check it for yourself, although be warned, it's not the most readable code in the world. We'll take the example of these needle files. They've been cluttering up my desk for a long time and I want to store them in something other than a yogurt pot. The files themselves are a fairly basic shape. It's just a cylinder with a fillet applied to it, and then I generate an ellipse just by squishing a circle. It's easier than figuring out how to actually draw an ellipse properly. And yeah, that is just has a prism applied to it, and then you have the base file shape. So this is just a transform applied over an array, nothing too exotic, but the function can be reused to transform other objects as well, which will be useful. So with that laid out, I decided to take 2D sections of these files, and to do that I used square face shapes instead of planes. The reason I did this, I know OpenCascade has a section algorithm, but it tends to give you an unsorted bag of edges that it's hard to do anything useful with, and I prefer this Boolean operation, which then gives you like filled faces for the solids. So I use that to generate ellipse shapes from where the files intersect the planes. So I'm using another useful component of the library here, the geometry properties. This allows you to do things like find the center of mass, what I'm doing here, or you can use it for like the area of face, volume of a solid, etc. So that's what I do here, and then I connect these center of mass points, making a polygon, which I then convert to a face. By themselves, the polygons are not terribly visually interesting. If you imagine sweeping a profile between them, it would be kind of faceted. So what I do to introduce a bit of extra complexity is basically add circle faces on each of the vertices of the polygons. And the result is this kind of hippie star shape thing.
Oh, behave.
So I've kind of struggled in the past with fusing coplanar faces to make a single contiguous face. The combination I found that worked for me here is a Boolean fuse followed by a so operation, and finally the shape upgrade unify same domain function with B-splines concatenated. Now I know you're thinking that's a huge mouthful, and it is, but I'll put it on the screen. It's fairly simple just to put these in a function together and then never look at them again. I now do two sets of z-dependent offsets for these profiles. There's not a particular reason why I did two, it just kind of worked out that way. This kind of offsets the base a bit more and preserves more of the detail towards the middle. An interesting thing I found, but I didn't end up using, was that you can apply a positive offset followed by a negative offset to essentially remove definition from a 2D profile. So that was kind of cool. I didn't use it here, but it might be useful in the future. So here I use the brep offset API through sections, I believe it's called, function. This is quite a useful function. I used it without ruled surfaces, so essentially OpenCascade does some kind of, I think, a Bezier interpolation. It can be tricky to get the resulting loft to be stable if the profiles are very close together, so it took some tweaking here. But in the end I ended up with this profile. After this point we have a solid, and it's basically a bunch of Boolean cut operations. I want to break up the flat end of this surface, so to do that I generate an internal kind of void using the same principle as offsetting shapes, but this time I use a negative offset, so it's a smaller subshape, so it cuts out this kind of nice curved profile. Here I'm reusing the function I created earlier to pattern out these files, but this time I'm doing it with a different shape to generate what I'm calling a countersink. Probably doesn't meet the strict definition for one, but that's what I call it. This is to kind of give you some indication of like where you want to stick the file, what angle you want to stick it in. At this point it's basically done. I just drilled a hole through the center, and for some reason I decided to embed a couple of hex nuts in the bottom. It's something about being able to attach things to other things. I like to have the option. I don't know. Maybe it says more about me than anything else. Yeah, so that was a fun little project that kind of used OpenCascade's capabilities. I thought it was a fairly good result as well. One of the nice things about this is that the algorithm, if you call it that, used is generalizable to different numbers of what you want to store or different shapes, things like that. So it's kind of very flexible. Could you do it using general purpose CAD software? I'm sure you could, but it's still kind of fun to explore the options you get with programming. Hope that was worth watching, and hope it was useful in some capacity. See ya! Here's the finished design. Not too bad. It fits all the files. Shit.